This is geometry notes, section 4.4. Notes 24, prove triangle congruence by SAS or HL. Put your name, date, and class period, please. Your essential question is, how can you use two sides and an angle to prove triangles congruent? And the way to do this, to answer it, is that to use two sides and an angle to prove triangles congruent is to have the angle in between the sides, or have a right triangle for the hypotenuse and the leg. We'll prove them congruent. Okay, if I go with the first one, it says identify the parts of a right triangle. Over here on the side, I have a right triangle, so that means there's a right angle or a box in the corner. And to identify the parts, the bottom edge here that share the sides of the right angle are called the legs. And this side opposite of the right angle is called the hypotenuse. And then the angles, these angles here, let me bring it up here, these are acute angles. Okay. We have postulates that have to go into our congruence magic book. We have the side angle side, which is the SAS, which you had in your book, SAS. And then on the back side, where we had our last definition, I'm going to write in our new one that is following what we have here in the writing. So you need to copy it down into your booklet, or you can summarize it yourself, whichever you prefer to do. Okay, here it is. It says two sides and included angle of triangle 1 are congruent to two sides and include the angle of triangle 2, then the two triangles are congruent. Okay, if I open it up, I got to put my example inside, which is going to look like what we have on our paper. So we have it in our booklet. Okay, so we have it filled in. We have to write our answers on the side as well as in our notes. So let me change markers. And I don't know how well this is going to show up. But this shows that RS, this segment, has two hash marks. So the corresponding side would be TU. Angle R has one arc, so its corresponding side will be angle U. And then RT is on the bottom, it has one hash mark, so its corresponding side will be UW. Therefore, the triangle, notice this is a side angle side, and here is your included angle. The included angle must be between your two sides. That's why it said included. So that means this is congruent by side angle side, because this is RST, so this would be UTW for a congruent triangle. Okay, make sure you translate over into your notes the same exact information that you had in your flip book, so that you have the two references that you're using. Alright, we have theorem 4.5, which is actually a number that I'll change later. Hypotenuse leg congruency theorem. This is when you have right triangles. Okay, very, very important. When you see that you have a right triangle, you'll no longer use side, 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 or side angle side. These are for any triangles. HL, hypotenuse leg, that's what this actually stands for, which is on the back of your flip book, is for hypotenuse leg. So it says, alright, if the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and leg of a second triangle, then the two triangles are congruent. So I need to put this into our book. So if I open it up flat, where you can see both the name and the definition, and then I flip my book over where I had HL, what I'm going to do is I'm going to draw the picture . Okay, so that I have this representation. Realize I'm going to put hypotenuse. I'm just going to put hypo with hypo, and then the single hash mark is my leg that represents my HL, hypotenuse leg. So I can say that triangle ABC is going to be congruent to triangle DEF by HL. In the same instance, we have LA. I'm going to write the same exact, or I'm going to copy the same exact triangles from above. Can't see that. Let me change markers. Let me go back to my orange. Okay. Have a right angle. Okay, so I have the same triangle from above, but this time I have an L and an A. Well, the L means a leg, so pick a side, doesn't matter which, but make sure it's corresponding. That'll be my leg. And then the A stands for an acute angle. Okay, so I need an angle. It's acute angle. So that means I can either pick B or C, doesn't matter which. I'm going to pick C. Its corresponding side would be F, so that I have an angle that I'm referring to. If I have an acute angle and a leg, regardless of which ones they are, if I have just one of those two things, then that means that the triangles are congruent. And this one would be by LA. Okay, let me go with LL. I'm going to once again draw my triangles that I had from above. because I have right triangles with these theorems. And now LL, can you guess what that's going to be? That would be leg, leg. So that means I have corresponding sides and corresponding sides here. So I need both legs in this setup so that I can say AB is congruent to DE and AC is congruent to DF. If I have that situation going on, then I know that triangle ABC will be congruent to triangle DEF, and that would be by LL. Realize these are all with right triangles. So here on the side, I'm going to put right triangles. Okay. This side is dealing with right triangles, HL, LA, and LL. CPCTC is totally different. We'll handle that one at a later date. But these are right triangles. Okay, put your book to the side. We're through with that for now until a later date. And let's go back to our notes. We have to write a proof given the information from the picture. The first one, it says number 1, it says JL is congruent to its corresponding side, which is LN. And then it also says KN is congruent to MN. And that is the markings that they have on their triangles that you can see there. They have single hash marks and they have double hash marks. So then they're saying, okay, well, 1 is congruent to 2. Well, how do we know that 1 is congruent to 2? Well, if I'm looking at it and I'm trying to figure out what's going on. Okay, if I look at number 2, I think I messed up my picture just a little bit. This was supposed to be a straight line going across and a straight line going across because this was supposed to be the vertical angles. Congruence theorem. So my picture kind of messed this one up a little bit. This is supposed to be straight. So that's showing that these two angles are congruent to each other. If that is the case, I'm looking at my proof. Here is a side, here is a side, and here is an angle. And be careful how you label this stuff because you can see a bad word in there. But realize on your picture that would be a side, and the angle is in between the sides. That is the concept of included that they have right here, is when the angle is between the sides. That's where this is falling to side, side, side. Congruence postulate. Sorry about that. My picture messed up my proof there on that picture. Alright, example 2, it says in the diagram ABCD is a rectangle, so that means the corners are congruent because they're 90 degrees, and it also means opposite sides are congruent based on properties of a rectangle. So what can you conclude about those two triangles? Well, if I look at ABC up here on the top, and my D did not print, so this is a D corner, and CDA, I can say that the two triangles are congruent because I can say ABC is congruent to CDA by, and if I'm looking at this on the triangle, on the rectangle, I know that this side is congruent to this side. So that means AD is congruent to BC, and actually that should be CB to have it correctly oriented, because opposite sides of a rectangle are congruent. That also tells me that opposite sides this way, on top and bottom, that means AB would be congruent to CD. So those are my two sides. And then I have that the corners are congruent to each other because they're 90 degrees. So I have that angle D will be congruent to angle B. And knowing that I have side, side, and then included angle here, that could look like side, angle, side. But it's not side, angle, side, because of that right triangle, or that right angle right there, this falls into the hypotenuse leg, or, whoops, where's my book? Because it's a right triangle that falls under either the hypotenuse leg, the LA, or the LL. So if I'm looking at what I have, these no longer are sides, they are legs. So these are the legs, so this is by LL. There is an alternate version that you could use. It's saying here that this was reflexive, that AC is congruent to AC, and then you could use the hypotenuse and the leg to prove it congruent. So there are many ways to show that these two triangles are congruent to each other. You just have to back it up with your evidence. Alright, next page. On the back, we have another proof. It says write a proof. It says AC is congruent to EC. That's the given. Then it says these two segments are perpendicular. That's also the given. But if they're perpendicular, that means that B and D are right angles. And that's because of the definition of perpendicular lines. And then if that's a right angle, that means this triangle and this triangle are what kind of triangles? That means they are right triangles. And that's definition of a right angle or right triangle. And it says AC is a bisector of BD. AC bisects BD. Oh, I'm sorry, I missed it. I was thinking for a minute. That is part of our given up at the top. If it bisects it, that means C is a midpoint, which means that BC is actually equal to CD by definition of the bisector. And so if I'm looking at this, I have a right triangle. BC is a leg. AC is across from the right angle, so that means this is the hypotenuse. So somewhere in here, let me find them. So BC, here's our leg. So there's the L. And then it tells us we have a right angle. Okay, that's our right angle setup. And then up here at the top it tells us you have your hypotenuse the same. So these two triangles are congruent by our HL postulate. Actually, it's a theorem, sorry. Okay, I want you to try the independent practice problem looking at what is given to you. So draw your proof, which will be your statements and your reasons, and we'll try this. I'll give you about 5 to 10 minutes to try to solve this, and then we'll go over it and see what you came up with.